Welcome to part 2 of the first tutorial. In this tutorial, we'll discuss further on Python basics and specifically we'll discuss if-else blocks, functions and classes. Let's get started. Let's start with if-else blocks. So these are blocks of code that control the flow of execution based on certain conditions or conditionals. So they always contain conditionals, and conditionals are statements that either return a true or false value. Let's look at an example of a conditional. Let's say a is equal to 10 and we execute this line a less than 13. Definitely 10 is less than 13, so this should return us true, which is a conditional. Now let's say we make a is equal to 30, and if we execute it, a less than 13 conditional now returns a value of false. Now in if-else blocks, the syntax goes like this. So we always start with a keyword if, and then we provide a conditional and then a colon, and within the colon with indentation we print the lines of code that need to be executed when the conditional within if returns a true value. And the other blocks are optional, so there's an optional elif block that should always be after an if statement or after another elif statement, and again this also contains a conditional, and whenever this conditional returns true, the blocks of code are executed within elif block, and if this is not true, it goes to the next elif statement or the else statement if it exists. And basically the else statement should again always follow an if or an elif statement, and if both the if and elif are false, the block of code within the else statement gets executed. Now let's run this example. So we have assigned a value of 10, and then in the conditional of the if block we say a less than 12, then this block of code gets executed. Now once this gets executed, your block of code comes here to the elif block, and once this if block is executed, the other elif and else statement won't get executed. Now let's run this as an example. So we see a is less than 10, so the if blocks gets executed and the other elifs, else, etc. do not get executed. Now if for example we make this 20 and we rerun this, the if block won't get executed because a is greater than 12, but the elif block is true, so elif will get executed and the else block won't get executed. So if we run this again, only the print statement between 12 and 50 gets printed out. Now say we provide a value greater than 50 here, so let's say 60. Now both the conditionals of if and elif are false, so the else statement will get executed, so it will print greater than 50 here. So if we again execute this, we see only greater than 50 getting printed. Now the important thing to note here is that an elif and an else cannot exist without an if block. So if we comment this statement out and try to run this, it throws an error saying invalid syntax. Basically we cannot have an elif without having an if block. However, elif is optional, so we can remove this elif part and still execute this code whatever number we give. So even if we give 20, the else blocks gets executed every time if is skipped, and we can have multiple if statements, elif statements and elf, but we can only have a single else statement associated with every if statement. For example, let's say instead of having elif here, we make it if and uncomment this. So we have one if statement, we have another if statement, and this else block is associated with this if statement. Now let's say we pass a number, say 25. So the first if statement should not get executed. The second if block should get executed because a is less than 50. It should print between 12 and 50, and else won't get executed here. So this is valid. So these are a few examples. Now another important function, we have not discussed function, but we will get to that later. Another important function takes the keyword isInstance. So isInstance is an inbuilt keyword in Python that takes two arguments within brackets. The first argument is any data and the second argument is a data type. For example, here we have given 12 and int. So the first argument is 12, that is some data, and int is a data type reserved keyword. So if we run this, basically is instance returns true if the first argument has the data type mentioned in the second argument. Clearly 12 is an int, that's why it has returned true. Now if we make this 12.1, which makes 12.1 a float, is instance should return false. Similarly, we can put a string here, let's say ABC, and we make the second argument as str, which is a reserved keyword which mentions the type of data string. So if we run this again, we get a true value. So this is a function called isInstance. Now we have a simple exercise. We have a list that contains some integers, some strings, and the list again contains another list 1, 2, 3, and so on. So our task is to loop through each element of the above list and print all str type objects. So to do that, let's write a for loop. So say for I in A. Now I iteratively assumes every value present inside the list A. Now we can use the isInstance function within an if block to execute our desired functionality. So we want only if I is of type str, and we provide this to the function isInstance. So only when this isInstance statement becomes true, we need to print out I. So if we run this, we see only ABC and 8.2, which are the only strings in list A, getting printed out. So that's our brief discussion on conditionals. Now let's go to functions. So functions are blocks of reusable code that can perform a specific task, and this is the syntax of writing a function. So every function has a name. So this function has the name my function, and it's by convention that names of function are always written in lowercase letters separated by underscores that act as separator for words. For example, this function has two words, my and function. Both the words are written in all small letters, and both the words are separated by this underscore. So every time we define a function, we have to follow this syntax. We first have to type the keyword def, followed by a space, then followed by the name of the function. Then within brackets, we need to provide arguments that the function needs to take. Then after that, we write a colon mark, and within indentation, we write the blocks of code that are necessary. And finally, it's optional to return some value, the values that the function should return. Basically, this function returns A, B, C, etc. You can return a single value, multiple values, or you can choose not to return anything. Now let's look at an example function. So let's create a function called toIntSum that takes in two variables. Let's call those variables x and y for now, and it returns the sum of these two variables. So it returns x plus y. By the name of the function, you can guess that we intend to return a sum of two integers. Now let's run this. So after we run this, Python is aware that a function named toIntSum exists. Now let's call this function. To call this function, we basically have to type the name of the function and provide all the arguments that the function takes. Basically, this function takes two arguments, x and y. So we provide, let's say, x equal to 3 and y is equal to 10. It's not necessary that you write these. So the order in which you provide the arguments are automatically assumed by the keywords in the same order. So just for clarity, let's assign x the value 3, y the value 10. And if we run this, we get the function returns the value x plus y, that is 13. Now it's essential that you provide as many arguments that a function is designed to take. For example, we provide 3 arguments now, say 3, 10. So even if we just write 3, 10, it returns the same thing, 13. Now if we provide a third argument, let's say 5, and we run this, we get an error, and the error reads toIntSum takes 2 positional arguments, but 3 were given. So the error is saying that the function is designed to take only 2 arguments, but more than 2 arguments are given. Similarly, if we provide less than the number of arguments that the function is designed to take, it will again throw an error saying 2int sum missing one required positional argument, that is y. And this is about how to call a function. There's another thing that we can do while defining a function is we give a default argument to one or many of these arguments, and whenever we do not provide a value for this argument while calling the function, the default argument is assumed by the function. For example, let's assign y is equal to 3 and rerun this definition. This means that 2int sum takes in two arguments, but whenever you pass a single argument, it always assumes that y takes a value of 3. So now if we run 2int sum with a single argument of 3, it will assume that y is also 3 and it will return 3 plus 3, that is 6. So this is how we can provide some default arguments to a function while defining a function. Now let's take a look at a simple example. Now the exercise says create a function say hello. The name of the function is say underscore hello, which takes the name of a function and prints a message saying hello to that person. So the argument to the function takes in one value, and that should be a string corresponding to the name of a function. So let's define this function. So we start with def. The name of the function is say underscore hello, and the argument, we need to provide one argument. Let's name this argument name. We provide a colon mark, and within indentation we print within strings hello and then comma name. So basically, if name is a string, print basically append this string one after the other. So hello is a string, then name should also have a string, and there should be a space between hello and name. So let's provide a space here and let's run this. And now let's call this function, just say hello, and we provide a string here. So name is say Rahul. And if you print this, the function returns or the function prints out hello Rahul. Now notice that unlike the previous function 2int sum, we did not return anything. So by default, whenever you do not return anything, a function returns a none type object. So just like there are ints, floats, etc., there's another data type called none. So this is a reserved keyword, and if we print this out, print the type of this data out. So if we print type none, it shows none type. So whenever you do not return anything, the function by default returns none type. To show you that, let's assign the return value of our function say hello to a variable say a, and then let's run this. So say hello is executed, the line hello Rahul is printed, and the function returned its value, some value, and it's stored in variable a. Now if we print a, let's print it, we get none, and again if we print the type of a, we see it's none type. So that's our brief discussion on functions. Now let's go on to classes. So classes are basically blueprints of any custom data type. So every data type we have in Python, for example lists, tuples, dictionaries, have their own rules. For example, how you index a list or how you index a dictionary using keywords, etc. Using classes, we can create our own data types. And another thing that you would have noticed is whenever we print a type of some object, we always get class followed by the name of the object, meaning all data types in Python are actually classes. And now let's use classes to create our own data types with their own rules of addition, subtraction, or whatever we want to define. Again, there are some conventions that we need to follow while naming classes. The usual convention is we use cap words while defining classes. That means all the words start with capital letters and there are no spaces between two different words. So for example, here we have defined a class named my class. There are two words, my and class, and these two words start with a capital letter and are not separated by anything, no space or no underscores. Now a class can contain multiple variables and functions within them. So all variables within a class are called attributes and all functions within a class are called methods. Let's briefly look at what is the syntax to define our own class. So the syntax is such: we start with the keyword class, followed by space, we write or we specify the name of the class. Then these brackets are optional, but I recommend you always use these brackets. And then we provide a colon mark, just like functions. And then within an indentation in the class, we define all our methods that are necessary. The important thing to note is that whenever you define a new class, you typically start with a default method called underscore underscore init. So these methods are called dunder methods or magic methods. And init is a method that defines how you want to initiate a class. For example, uh, this class has an init function that has several arguments, excluding the first argument. So we will look into details of what the first argument means. All other arguments that are defined within the init function of this class are necessary when to define a class. So let's take a look at an example. Let's say we want to define a class that characterizes a person. So let's call this class person, and it stores the name and age of a person. So this is our custom data type named person that is used to store the name and age of a person. So let's define this class. So we start with the keyword class, and then we write the name of the class in cap words, that is person. And after brackets and colon, because this is a new class, we should write an init function whenever we define a new class. So I write def underscore underscore init, then double underscore, opening and closing brackets. And now the first argument of our init function should be a reserved variable, that is that is not an argument when you start creating a class. So by default, these reserved arguments are always named self, but it's not necessary to do that. Just to show you an example, let me call this variable as resvar, that stands for reserved variable. And then we provide the necessary arguments needed to define a person class. So that is, let's say, name and age. And within this function, let's store the name and age of whatever person we want to create within this init class. So we call this reserved variable resvar, and we write dot n, and to this variable resvar dot n, so this variable is basically an attribute of the class. We assign name to this, and to resvar dot a we assign age. And let this be all for our simple class. Let's run this and create a data type of type person. So every instance of a class that you create is called an object of the class type. So for example, I want to create uh, an instance of person assigned the variable Rahul. So Rahul is called an instance of the class person or a person object. Now whenever we define person, we need to provide name and age, because that is what is mentioned in the init function of this class. So we say name is Rahul and say age is 42, and let's run this code. Now Rahul is an instance of the class person. So if we type, if we find out the type of this object Rahul, we see it reads main dot person. So it basically says it's a data type of type person, which is our custom class. And now we can access the name and age of Rahul as such. So we just type rahul.a, that stands for age, because resvar.a stores the age. Now if we just run this code, we get the age of the instance of the person class. And similarly, if we type rahul.n, we get the name that is stored. Now if we create another instance of the person class, and we provide name is equal to Sachin and age is equal to say 40, and if we print out Sachin.n and Sachin.a, we see the name Sachin gets printed out and the age 40 gets printed out. So this is a simple example of how we create a class, how we write an init function, and then how we create instances of the class, which are called objects. Now let's look at another example that contains an additional method in addition to the init method, the default init method. So here we create a class named material, and in the init function, the first argument is the reserved variable. So by default, we are calling it self. And whenever we define material, it needs to take 3 arguments. So the 3 arguments are name, state, and density. All these 3 arguments are stored within the init function in 3 attributes: self.n, self.s, and self.d. Now in addition to this, there is another method within the material class called getNickname. And the first argument of getNickname is again the reserved keyword. So there can be methods within classes that do not take the reserved keywords, but we will not go into those details because this is what we will need for this course. So the first word is again self, which is reserved. So basically whenever we call the getNickname method within our material class, we need not provide any arguments because this is the only reserved arguments, and following this there are no arguments. Now what this method does is it collects the data that is stored in self.n. So self is basically the handle that helps it access all the attributes of the existing object of that class. So it can already access self.n, and it stores this as a variable symbol, and then it creates another attribute named self.nickname, and it stores the symbol in this attribute, and then it returns the capitalized version of the symbol, basically returning the same string but making the first letter of each word capital. Now let's run this class and try to try to make an instance of this class. So for example, we create an instance aluminum, which has the name aluminum, state solid, and density to be 2.7. Notice that since our init function had these 3 variables, whenever we create an instance of the class, we have to provide these 3 variables. Now if we run this and print the type of the aluminum variable, we see that it prints main.material. So it's an instance of the material class. Now note that if we do not provide one of these arguments, so we do not provide density here, let's say, when we run this, it throws an error saying the init function missed one required positional arguments. This is similar to a function because init function is also a function that gets executed by default whenever you create a new class. So now let's just provide density to be 2.7 and rerun this. Positional, okay. So let's specify this is density. Now once we have created this aluminum object, we can access the attributes that are mentioned in the init method. So in our init method, the self.n attribute is already defined, so we can call aluminum.n. Now what would happen if we call an attribute that is defined in some other method? For example, the self.nickname attribute is defined only in the getNickname method. So if we try to access this, we see an error saying material object has no attribute nickname. That means that this getNickname method within this class has not yet been executed, and hence the object is not aware of the existence of this self.nickname attribute. However, if we just call this aluminum.getNickname method first, so it returns a value aluminum, it returns capitalized name, and then we try to access aluminum.nickname nickname variable. So it prints out aluminum. That basically has 2 messages. The first is whenever you create an instance of the class, the init method gets executed by default. That's why all the attributes that are present within the init method can be accessed as soon as you create an instance of the class. And all the other methods that are there, the non-init methods, these are not executed whenever you create a class, but you can later execute them and make use of the functionality that they have. Now let's take a look at another important concept within class, that is called inheritance. So for example, you already have a pre-written class like material and you want to add some new features to this pre-written class. So for example, we have a class named material and we want to create another class called conductor that has all the codes that is there within materials and then add a few new lines of code. So we can do that by something called inheritance. And the way to do this is to follow the following syntax. So we again create our new class as usual, and within the brackets we provide the name of the class from which our new class wants to inherit. So here's a simple example where our new class conductor inherits from the pre-existing class material, and we do not write any additional lines of code. So we just pass, so within the indentation we just write the keyword pass. That means all the code within material is now, so because conductor inherits from material, now conductor is aware, the class conductor is aware of all the codes present within material. Now let's run this and try to create an instance of the new class conductor. Now because every material class needs to take name, state and density while initiation, the conductor class is also the same, and we create this instance named silver with the name with name as silver, state as solid and density is a 10.5, and then we print silver.n and silver.getNickname. Basically silver.n, this .n attribute has already been defined in the init method, and getNickname is another method that has already been defined in the material class. So if we run this, we get, so silver class is successfully created, silver instance of the conductor class, and then we can access silver.n, and we can also run the method silver.getNickname. Now we can also override a few functions that are there within our parent class. For example, let's look at an example of semiconductors, where this semiconductor class requires the name, state, density as well as the band gap to get initiated. So for that, we inherit from material and we want to rewrite the init function, because the material init function only takes 3 arguments, but for semiconductor we want to give 4 arguments. So we just rewrite the init function. So we say def underscore underscore init, and then we provide the keyword and whatever arguments are necessary. And then we can, within this init function, we can write our own code here. So in this example, we want to repeat whatever was there within the material class. So to do that, we call this super function that calls the parent class, and within the super function, we call the init function of the parent class. And because while in this call, we are not defining init, we need not provide the first argument that we call, that is self. So we basically called the init function of the parent class and passed it the name, state and density of the current init function. So it basically executes the init function of the parent class, and then we write an additional piece of code, that is self.bandgap is equal to bandgap. So the additional information is stored in self.bandgap attribute. Now let's run this and try to create an instance of this semiconductor class. So we call semiconductor, we provide the name, the state, the density and finally the band gap, and we store this in a variable named silicon. Now notice, now we can call silicon.bandgap here. That is 1.1, and yeah, so we can also call the other methods. Let me change this one. So we can also call silicon.n. We can also call silicon.d, that gives density. So silicon.n and silicon.d have been defined in the parent class. Now the getNickname method has also been inherited because we didn't change this method, and this method was already there in the parent class. So we can also call this, and it returns the capitalized version of the name. Now let's take a look at a simple exercise. So the exercise says, construct a class insulator that inherits from the class material and add a new method getBandGap, which returns a string really high. So our new class name is insulator, and it should inherit from the class material. So let me autofill this. So Python is already aware of the existence of material class, so we can autofill this here. And then we write colon. We need not make any changes to the init function of the material. So that's not provided, that's not part of this example. So we skip that, but we create a new function called get bandgap. So let's create a new method, get bandgap. And like every usual method within a class, the first argument should be the reserved variable. Let's call that self. And this new method does not take in any other arguments, and all it does is it returns a string. So we'll return return a string reading really high. So this is our insulator class. And now the next part is create an insulator object named wood with name wood, state solid and density 0.9, and call the get bandgap and get nickname methods. Notice that get nickname methods gets inherited from the material class. So let's create an instance of the insulator class named wood, and that is an instance of insulator. The name is wood, state is solid and density is 0.9. And after that we need to call the get bandgap method of wood. So wood dot get bandgap and wood dot get nickname. So these two methods do not take any arguments, and if we run this, we get only wood here. So because these methods return strings, in order to print them out, we have to provide the print statement. Otherwise, it only prints out the last string. So let's add print statements here. So we rerun this, we get the result of get bandgap, that is really high, and the result of dot get nickname, that is wood with capital W. Yeah, so this is running them separately. So this is our brief discussion on classes. Now let's get to the final part, that is scope of a variable. And let's look at this concept with the help of an example. Let's take a look at this piece of code where we define a variable named x is equal to 10. Then we have a function named my function that defines another new variable y is equal to 5. Then it prints x and it prints y. Notice that it does not take in any arguments. Now since x is already defined, my function and x is defined outside the function, my function will be aware of the existence of x because this is something called as a global variable, because this is defined outside the function. Now y is also defined within the function, so it prints out y. Now after we come out of the function, we call this function. Basically whenever we call, the codes within the function get executed, and after that we print x and print y. So if we run this, let's see what happens. So when we call the function, x and y get printed out. So 10 and 5 are printed. And then when we try to print x here, 10 rightly gets printed out. But when we print y, there is an error saying y is not defined. That is because the y variable is only defined within this function my function, and beyond this Python is not, so after we get out of this function, Python is not aware of the existence of this function, of this variable. That's why it throws up this error saying y is not defined. So one way to get rid of this is to say that I am declaring a global variable named y. So we can do that by typing global y here. That means within the function itself we created a global variable, and after this is done, the entire code should be aware of the existence of y. So if we print this out, now this gets correctly printed out. Now even outside the function, because we already say that we are defining a global variable, print y works. Now this is not a very good method of good way of declaring global variables within y, but this is just to show you that this exists, and you have to be careful that you do not encounter or get into this error when you run your own code. So this is all from this tutorial, and thank you for joining, and I'll see you in the next tutorial.